Introduction to Quantitative Analysis. Other terms you may hear that are interchangeable include operations management, operations research, or management science. All of these terms refer to a scientific approach to managerial decision making. Mathematical tools have been around for thousands of years. However, the concept of applying quantitative techniques to decision making was developed in the past 100 years or so. A major advantage to these techniques is that they can be applied to a variety of different problems faced by management. When using these techniques, you must understand when to apply the technique and its limitations and assumptions. Ultimately, you measure success with a timely, accurate, and easy-to-use solution. A company that has successfully used quantitative analysis is NBC. In the late 90s, they utilized quantitative models to improve their sales plans. They continue to use new models such as random forests for directed marketing. They use these algorithms to determine what kind of products a customer is likely to buy and then advertise to them those products. Basically, they want to classify what kind of product you are most likely to buy and then advertise that product to you. Our goal with quantitative analysis is to collect some raw data from within our company or from our customers, apply a quantitative model such as the ones we're going to learn in this class, and then finally produce some meaningful information that we can use to make a decision. Or, if we're an analyst, we may do this or supply this meaningful information to our superiors, and they can use it to make an informed decision. When making a decision, we need to consider both quantitative and qualitative factors. Examples of quantitative factors might include different investment alternatives, current interest rates, inventory levels, or the demand for our products, or the cost of labor to produce those products. Some qualitative factors might include the weather, federal legislation, or technological breakthroughs that make some products obsolete. Business analytics is a data-driven approach to making decisions that uses large amounts of data and applies statistical and quantitative methods to analyze data and provide meaningful information. Three basic forms of analytics we will use are descriptive analytics, which is the study and consolidation of historical data. A kind of analysis that this would include would be finding the average amount of product sold. The second kind of analytics we'll be interested in is predictive analytics, which we can use for forecasting future outcomes based on patterns in past data. Basically, we want to know what we think will happen in the future, and that's what our models will tell us. The last form of analytics is called prescriptive analytics, and it uses optimization models such as linear programming to prescribe what we should do in the future. So between these three kinds of analytics, we can solve different kinds of problems. The quantitative analysis approach has 7-step process that we will follow to ensure we make the best possible decision. The first step in the process is to define the problem. We need to develop a clear and concise statement of the problem to provide direction and meaning. This may be the most important, but also the most difficult step. We need to go beyond the symptoms and identify the true cause. we create a specific and measurable objective, and experience has shown that poor problem definition is a major reason for failure. The next step is to develop a mathematical model of the problem situation. An example of a mathematical model is the graph here that shows a regression based on the amount of advertising dollars spent and how it predicts how much our sales will increase. Here, our decision variable would be how much we spend on advertising. Mathematical models usually contain both decision variables and parameters. Decision variables are measurable quantities that may vary or are subject to change and can be controlled by a decision maker. Parameters are inherent in the problem and are generally not in our control, such as the cost of placing an order. All models should be solvable, realistic, and the required data must be available in order for us to solve the problem. Data can come from a variety of sources, including company reports, documents, direct measurement, or statistical sampling. If the quality of our data is poor, then regardless of the quantitative process we perform, the quality of our solution will also be poor, also known as garbage in, garbage out. Developing a solution. When we develop a solution, we are going to manipulate our model to find the best or optimal solution. Some common techniques to do this are to solve a mathematical model, by trial and error, complete enumeration, which is when we try all possible combinations of solutions, and finally, if we use an algorithm, which is an iterative approach to get us closer and closer to that optimal solution. Testing the solution. The next step is to test our solution. We can do this by making sure that our model still works on a new set of data we collect. An example would be if we are predicting sales for a month. We can test our model on a different month and see if our results still hold or are valid. Thus, our results should be logical, consistent, and realistic. Now we need to analyze the results and determine the implication of our findings. The most important concept in this class is sensitivity analysis. We will talk about it in each of the different kinds of models that we perform, but sensitivity analysis involves determining how much the results will change if the model or input data change. Another name for sensitivity analysis is post-optimality analysis. The final step is to implement the solution to the company. Implementation can be difficult due to resistance to change, and changes occur over time, so we need to monitor our solution to make sure it is still the optimal solution. Quantitative analysis models are used extensively by real organizations to solve real problems. In the real world, quantitative analysis models can be complex, expensive, and difficult to sell. Thus, following the steps in the quantitative analysis process is an important component of success. To give an example of a simple quantitative model, let's look at a model for calculating profit. Profit is calculated by subtracting our cost to make a product from the revenue received from selling those products. Our expenses can be expressed in different ways. Fixed costs are expenses that do not scale with the quantity of a product produced. However, variable costs are expenses that are dependent on the quantity produced. Quantitative model, we want to determine our profit. Our revenue is based on our selling price times the number of units sold. Our expenses are constituted first by the fixed costs and the variable costs times the number of units sold. In this model, the fixed costs, the variable costs, and the selling price would be parameters, and the number of units sold is the decision variable. Let's solve a quantitative model. We have an example here of GameStart used games. They buy and sell and repair old video games. They sell their games for $8. The equipment needed to repair games has a fixed cost of $1,000. The material needed to fix one game costs $3. If we put these numbers into our profit formula, we find that if we are unable to sell any games, we will lose $1,000, which makes sense because that is the fixed cost we had to put into starting up our equipment. However, if we are able to sell 1,000 units, then we will make a profit of $4,000. This leads us to that a manager might be interested in. At what point do we actually start making a profit? If we manipulate our profit model, we can determine when the break-even point is. We set the profit equal to 0 and then solve for our decision variable. We find that the break-even point can be found by dividing the fixed cost by the selling price minus the variable cost per unit. If we use this concept on our previous example, we can see that at 200 units is when we will start making a profit at GameStart used games. We put in our fixed costs and our selling price minus our variable cost, and that calculates our break-even point. We know that sales of less than 200 units of used games will result in a loss, and sales of over 200 units of used games will result in a profit. Models can be categorized by risk. Mathematical models that do not involve risk or chance are called deterministic models. All of the values in the model are known with complete certainty. However, mathematical models that involve risk or chance are called probabilistic models. Values used in the models are estimates based on probabilities of unknown variables. There are possible problems in a quantitative analysis approach. Problems with defining the problem may include the problem is not easily identified, there's conflicting viewpoints between staff on what the problem is, as well as how it impacts on other departments. The beginning assumptions could be wrong, or the solution that we are trying to use is outdated. Problems with developing a model may include trying to fit textbook models to real-world problems without relaxing some of the constraints. Or there could be a lack of understanding of the mathematical model itself. The validity of the data collected, or hard to understand mathematics when developing a solution, or a solution that affects different departments and we do not look at the company as a whole. Or it's a solution that may benefit one department but drastically hurts another department. So we need to develop a holistic solution. Finally, during the implementation phase, major problems could arise if there is resistance to change due to uncomfortableness with new thinking patterns or a lack of commitment by management and staff to continue the change.